Hello guys and welcome. I hope that you're well. My name is I play 4K, aka I play 8K, aka I play 16K or HD King. During this video, I'm going to demonstrate CounterStrike Source PC game running in 16K video resolution. This is the world's first 16K video resolution gameplay in CounterStrike Source PC game that is real 16K native real-time rendered 16K video resolution. Okay, I achieved this resolution through the Nvidia DSR technologies, running it on a native 8K screen and 4x through the Nvidia DSR, so it's rendering in 16K resolution natively and then downscaling to 8K resolution and displaying on my screen. But keep in mind, exactly at the left top corner, exactly that much resources required for this system to be rendered 16K resolution, not the 8K resolution but 16K resolution, which is 4 times more in terms of the screen estate. But however, it's going to be about 3 point times less in terms of the FPS when you're rendering 8K resolution versus 16K resolution. Nvidia achieved absolutely amazing algorithms while achieving that rasterized render. Okay, so I benched the CounterStrike Source PC game version 3.4, the first version that was released in 2014 to PC consumers, to PC gamers, and to any gamers, and it was the Source game engine powering the CounterStrike Source PC game, and the same game engine was powering Half-Life 2 PC game as well. So I benched it without the recording with Nvidia ShadowPlay, but I'm recording this video today with Nvidia ShadowPlay, so it consumes a little bit of the resources, so FPS will be a little bit higher if I wouldn't be recording. I'm not recording today this video with external professional video recording device, but I'm going to do that in the future. So go ahead and support me, smash that sponsors, and I'm going to collect those pennies and invest back to you guys, and we're going to record with another external video recording equipment because I burned out my 8K resolution video external recording equipment that was very expensive unit, by the way. So here we go, 200 FPS without recording. Let's go ahead and find out how much with the recording, but this preset and this FPS was at the maximum possible visuals, including 8 times MSA. So let me go ahead and go to the options. As you can see, I'm using the zoom tool, zoom in, zoom out. This is zoom tool at 1000% on a 16K resolution. My desktop today is set to 16K video resolution as well. Keep that in mind, and it's very crucial when you're running games in 16K video resolution, especially on Windows 10. What I find out, you better set your desktop to 16K video resolution. Otherwise, it's not going to it could be not showing the proper FPS, because even if it's going to say full screen under the game, when you select the 15360 by 8640 pixels, just like I did, it's not going to be a full screen. It's going to be, most likely in a lot of games, it's forcing into the windowed mode even if it says full screen, and it's not seeing like it's windowed mode. So if your desktop is not set to 16K resolution, most likely you're not receiving the same FPS as you would at 16K resolution, and not the same resources you utilize. Hopefully guys this makes sense. So I'm using maximum possible preset. During this video I'm going to show all kind of different presets. I'm going to show you maximum possible presets, including the anti-aliasing 8 times MSA, then without the anti-aliasing, and then at the lowest possible preset. Okay, let's go ahead and get going, guys. I rebooted a couple times. I didn't see any difference, guys, with the MSA, without the MSA, but we are going to find out. So the built-in benchmark is going to be in menu, video stress test. I'm going to go ahead and click on it. As again, you're going to use the CounterStrike Source PC game version 3.4. This is the first version, keep that in mind. Without any mods, just to make sure that everything is right, because some mods can do some cheats and etc., and the performance could be different. So just a vanilla, just a classic version, just a retail version of the CounterStrike Source PC game 3.4. As you can see, FPS is beautiful. By the way, this is demonstration of the Source game engine by Valve that was released to the consumer in 2004, which is beautiful demonstration, by the way. As you can see, almost fakeish ray tracing right there, and that copper, it shows us the glass, it's showing us the water. Unfortunately, there is no caustics, but it's showing us the water and reflection and refraction in that water, as well as showing us kind of like a thick glass material, then like a mirrors, fire, everything is here, particles. So the game engine is ready pretty much to create anything what you like in 3D. You just gotta set the lights right and make it more artistic. And pretty much any game engine you can do that, guys, by extending it through some scripts or through writing some additional and adding some additional libraries. But this game engine, even in 2004, was ready pretty much. It can render anything, as you just saw based on that demonstration. 2 minutes of the base demonstration ever what is possible thanks to the Valve developers. They did the Source game engine properly, and they're working right now on Source 2 game engine. They're looking to transfer the CSGO, Counter-Strike Global Offensive, to Source 2 game engine, which is going to be on another level. But Source game engine is amazing game engine, except the demo files in that game engine. This is what they didn't pay a lot of attention. Everything else is absolutely amazing, but demo files are not compatible, and this is a big issue. When you're developing a game using the game engine, you want to make it structured properly so everything will be dynamic, but at the same time not going to ruin the previous experience of the previous game engines on the user. Hopefully, guys, this makes sense. As you can see, I'm experienced graphic designer, 3D artist, 3D animator, software developer, game developer. So during my videos over the EVGA.com, I'm sharing a lot of information and I have a lot of experience, guys. I didn't play a lot with the Source game engine. I played a lot with the IT Tech game engines and the Unreal Tournament first Unreal game engine. Okay, keep that in mind. Before I played with the Unity 3D with the modern game engines. But pretty much the idea is all the same. The modern game engines has some more features and more complexity to it, and more tools to work inside of the game engine without getting throughout third-party applications. So as you can see, within the ShadowPlay recording in real time. By the way, the ShadowPlay recording during this video was modified, and Nvidia driver was modified as well. So ShadowPlay recording is up to 8K resolution, and Nvidia DSR is up to 16K resolution. So if you have 8K resolution native screen, you can go 4x to 16K. It's locked. Somehow Nvidia locked this option for the consumer in 2022, and 16K resolution pretty much is, this is the world's first, as again, 16K resolution video test in CounterStrike Source PC game on YouTube ever, guys. And it's explained in the basic language, as you can see, and it's real deal. Keep that in mind. So don't forget to smash that like button. A lot of time, money, energy was invested. So I'm going to collect that pennies and visit my sponsors, and I'm going to invest back into you with the more quality content available over the EVGA.com. So we lost about 10 FPS from, as you can see right here, 189 FPS within the recording. Not bad. Beautiful performance. Let me zoom out. Let me go to the options. I'm going to change the video option real quick. Let me zoom in. And I'm going to disable the anti-aliasing, and what I'm going to do, apply, okay. I'm going to reboot the game. But also, guys, for those folks who's watching this video, they're like, oh dude, you forgot the FPS lower underscore max space 0 to unlock the FPS. I did not forgot that part. I didn't forget that part. Let me show you guys real quick. Sorry, I'm coming in real time. I'm focused at two different things. Let me show you something real quick that I used that command right here when I started the game. FPS max 0 right here. And this is the command that every time you're rebooting the game that you would like to use, unless you're going to put it in a config file, it's going to unlock the FPS, so you're not going to be limited in terms of the FPS. Otherwise, you can be limited to 300 FPS maximum just to unlock the FPS when you benchmarking CounterStrike Source PC game and trying to see how fast your computer versus my computer. Go ahead and do it. So I'm going to go ahead and reboot the game now, but you will see me typing this command, so this is exactly what this command is for. Okay, before we're going to jump into the game, let me show you real quick. By the way, this audio track is North Sea by Riot. All rights reserved. All commercial rights reserved. No royalties can be claimed. Provided by the YouTube. Thank you so much, YouTube, for this audio track. Let me real quick show you that my resolution. Let me show you that see, like 1000% right now zoom, so I'm using the zoom tool. That my resolution is set at 16K resolution. This is a very crucial part. Set your resolution as 15,360 by 8,640 pixels, which is 133 megapixels if you're going to round it, or to be exact 132.7 megapixels. But make sure to set it, because as again, some classic old school games saying full screen, but they're going to be forced to output to windowed mode and you're not going to see it. And if your desktop is not set to that resolution, you're not going to receive the proper FPS and not going to properly utilize your system and not going to show the proper numbers. Hopefully guys, this makes sense. 100% scale, very important as well, because what I find out sometimes on scale at 500% it doesn't show the proper FPS in some sort of games. Keep that in mind, not in all games but in some games. Okay, let me close this up and reboot the game. Here we go. Look how small my mouse cursor. This is just unbelievable right here at the right top corner. Okay, let me double check that resolution is ready for us, and I'm going to use the command, and we're gonna keep going guys. We gotta get going. So windowed mode, 16K resolution, maximum visuals, except the anti-aliasing is off. Exactly what we want to do. I'm going to bring up the console. Here we go, I just brought the console, and under the console I'm going to write a command, as you already know, FPS lower underscore max space 0, enter, and that's it. After that point we're Gucci here. I'm gonna close the console, zoom out, and I'm going to start the benchmark test. Here we go. Let's go ahead and have a look. FPS is unlocked. Really like this as again game engine demonstration. It just everything is right here and showing the power of the Source game engine that is ready for everything. Look at this. Multi-layered materials, one glass with the stone, then the glass, the thin glass, then the copper retracing, kind of fake retracing, a copper material, then the metallish look to it, then the water with the reflection refraction without the caustics though, because I would like to see some caustics everywhere on the walls and everywhere, but it's not here yet. And then the thick glass right here, and the copper could be used as a mirror as well. So everything was demonstrated here, including the particles. We didn't see the heavy smoke yet, the volumetric particles yet, but pretty much the Source game engine supports every single feature that is necessary to develop a game, even in 2022. It depends how professional you are, okay? But you can utilize it and you can develop a solid game. Keep that in mind. Alright guys, 191 FPS. Without the anti-aliasing, FPS didn't increase. This is exactly what I saw without the recording as well. I did couple benchmarks, was a little bit upset, reboot the computer, didn't increase the FPS. So look like 8 times MSA under the CounterStrike Source PC game is no problem for Turing GPU architecture that is powering today our Titan RTX video card with TU102 chip. Okay, and 24GB of video RAM. So I'm going to go ahead and close that. And I'm going to go ahead and change the settings to minimum as possible visuals. This is going to be the last test, and I'm gonna test that. For those folks, I know some folks was asking, so don't forget to smash that like button. This is an extra bonus for you. Everything maximum possible visuals, apply, okay, and I'm going to go ahead and close the game. Here we go, and reboot the game again. Real quick, use the command under the console. So FPS underscore lower underscore max space 0, enter. Closed it up and double check that everything's set to minimum. It should be to minimum. Here we go, 16K resolution, everything set to minimum. excellent. Keep in mind, guys, that I recorded 8K resolution under the same system available over the UHDking.com, as well as I'm going to record 12K resolution on a single Titan RTX video card and 2 Titan RTX video cards in SLI, because CounterStrike Source PC game supports SLI, so stay tuned for that. We're going to find out what's going on with this game engine in depth. But something is limiting my GPU usage. It's still 97%. It's excellent GPU utilization, but the FPS, as you can see, is not changing by a lot. Something is limiting. I'm not sure why it is. Maybe a game engine itself, or maybe Turing GPU architecture is too fast. It's receiving so much FPS that Nvidia drivers decide not to improve in terms of our FPS, even when we're switching down the anti-aliasing. But the only way for us to find out when I'm going to add the secondary Titan RTX video card in SLI to the NV link, and we're going to test it, we're going to find out. Because the source game engine was using DirectX 9C, as I remember, I think shader 3.0, model shaders of 3.0 on the hardware, on the video cards. During that time, I had the Radeon 9000 series video card, keep that in mind. When Half-Life 2 and CounterStrike Source was introduced to us. Let me go ahead and have a look at the minimum possible presets. As you can see, FPS is still at 200 FPS, just like exactly scenario, just like when I didn't record and I did a couple of reboots, it's still the same way. So I'm not sure what it is. Let me know what it is. But as again, we are not limited by the FPS. Keep that in mind. So pretty much, guys, that's it. You saw at the left top corner, data was updated every second, self-explanatory. As you can see, I'm getting more professional, and while recording my videos now, better audio, monitoring tools much better, video quality are amazing, was always amazing, but right now on another level. I'm collecting those pennies from your ads and about to purchase the 8K video recording professional external equipment, so we're not going to lose any FPS. But I'm really in love with Nvidia ShadowPlay software. I think it's one of the best software that Nvidia did ever. So okay, everything is here. Let me real quick go ahead and explain to you about my computer. But as you can see, the photo of it on the wallpaper already taken with my iPhone XR. It's beautiful, water cooled with the H150i, as you can see, by Corsair, and the Titan RTX still running stock 2-fan air coolers, okay, but they're running on the liquid metal thermal compound paste, which is 3 Celsius cooler than stock Titan RTX video card by Nvidia. Keep that in mind. Guys, as we saw that RTX 2080 Ti video card can do the same in CounterStrike Source PC game, because the VRAM utilization was not above 11 gigabytes, and RTX 2080 Ti pretty much the same video card as Titan RTX in terms of the GPU computing power, only limited by 256 CUDA cores, and it's lower by about 5-7%, and it's limited by the bandwidth, by the GDDR6 bandwidth, even if it's using the same GDDR6 by Samsung, but it's limited by the bandwidth. About 60 gigabytes per second less it can do in terms of the pushing the data for the GPU to compute. Keep that in mind. But anyways, let me explain to you what's going on the screen. Let me zoom in, and we're going to start with the CPU Z. So this is the CPU Z. As you can see, what we are looking as the gamer, we're looking at the single thread performance, okay? Because the multi-thread performance, where we are utilize all 6 cores. Today, by the way, I'm using only 6 cores, 6 threads on the i9-9900K. That is 8 physical core CPU and 16 logical threads, or 16 logical processors. But today is only 6 physical cores and 6 logical processors to achieve 5.3 gigahertz or 5300 megahertz frequency, okay, for the external frequency, and 52 multiplier for the AVX2 frequency, which is the 5.2 gigahertz or 5200 megahertz for the AVX2 frequency, okay, most used on the videos encoders, and when you do a lot of video encoders, all kind of different brands, third party, and a lot of them utilizing AVX2 instructions and AVX2 frequencies, and pretty much 3D rendering is using sometimes AVX2 instructions as well. But a lot of games using external frequency, but nature of the Core i9-9900K that is switching to AVX2 instruction frequency just to cool it down, just to lower the wattage, just to lower the voltage, just to when you're not using the CPU, whatever decide that you're not going to benefit or your CPU is running too hot, it's going to do that. Our CPU didn't run too hot, but because it decided it's not going to benefit, it was lowering to 5.2 gigahertz as you saw at the left top corner during our benchmark. And this is exactly what it is. I just explained it to you. It's the nature of the 9000 series Intel CPU. When we are talking 12,000 series Intel CPUs, it's going to be even more complicated things there because they're going to add more features to it. Please keep that in mind. So motherboard Asus 11 Hero using PCI Express 3.0, utilizing our bandwidth for Titan RTX and delivering the all kind of wattage and voltage that all kind of voltage and that is required, and all kind of data lanes, communication to CPU and system RAM if necessary, and yeah, even at 8x. I'm not sure why it's using 8x when it's PCI Express 3.0 16x, and even if I didn't install M2 storage drives, didn't install any other video cards, it's still doing that, or any other cards in the PCI Express slots, but it's still doing that. Anyways, I'm using the 3300 MHz 1650x2 3300 MHz CL11, very aggressive timing, which is unheard of for the DDR4 at 3000 MHz. Keep that in mind. 1T command, and it's unheard of fast. Okay, it's producing below 43 nanoseconds latency. This is unheard of. Okay, and dual channel, which is 128-bit. Also, I'm using the core cache frequency at 48 multiplier that is producing 48 gigahertz or 4800 megahertz, very fast as well. 32 gigabytes total for times 8 sticks. How I achieve that frequency and that latency delay, which is unheard of, because I'm using very rarest and very expensive DDR4 by Corsair 5000 MHz CL18, but it's unstable on any sort of motherboards except the MSI godlike for Ryzen AMD processors 5000 series. I have a doubt about it. So, but just because I know this is the Micron chips, this is not the Samsung chip, this is probably why it's not supported above 3600 MHz on this Maximus 11 Hero motherboard that is shoot, but just because it's Micron chip and they're not so great at the high frequency. Samsung chips are great at the high frequency. So Micron chips are great at the low latency. And as you can see, I'm utilized that latency pretty well. CL11, 1T command, and the frequency as high as possible as supported 3300 MHz on this particular motherboard. Okay, yeah, so be careful about this memory. For the Ryzen 5000 series, only MSI godlike is working with this motherboard. That's what Corsair told me, but I have a little bit of doubts. So as again, you're looking under the benchmark on the CPU-Z for the single thread performance core, which is 628, unbelievable, and 100 points faster than stock. Keep that in mind. And this is pretty much done based on the frequency. The higher frequency, the higher score. Keep that in mind. And then as well as by the instruction per core, per clock and per core. This is a very important factor. Instruction per core, instruction per clock as well, and then it's splitting per core. The higher instruction per core is better per clock. Keep that in mind. But the frequency, that clock, which is frequency, the higher frequency is better by itself. Hopefully guys this makes sense, because it's part of the algorithm, part of that formula. And of course multi-thread benchmark as again as the workstation for 3D rendering such as 3ds Max, Blender, Cinema 4D, where you're going to utilize all the cores. But as again, the more cores the better, and most likely for that type of scenarios I'm going to enable back to physical cores to make it 8 physical cores total, and I'm going to enable back the hyper-threading technology, because the hyper-threading technology is off, is disabled throughout the BIOS, and 2 physical cores disabled throughout the BIOS. This is why only 6 cores, 6 threads, okay, 6 logical processors is used, and I'm going to be boosted up here in terms of the score. But this is not what I'm looking for in terms of the multi-thread score. I'm looking in terms of the single thread score, and this is exactly what it is, 3950X. Let me show you some CPUs comparison. By over 100 points faster in terms of the single thread performance. As again, you're going to look at the single thread performance. Okay guys, 7980 XE Extreme Edition processor, over 120 points faster than that CPU. 10900K, even the newer CPU, but we're outperforming because it's overclocked at the maximum possible frequencies for the home safe environment today, our i9 9900K, and it's tuned on top of it for the best possible scenario, for the best possible FPS in games. Keep that in mind. I'm going to create a video tutorial how to overclock your i9 9900K like a pro. It's going to be the best guide. Do not miss it. It's going to be available over the UHDking.com YouTube channel. The best guide that you will ever watch. I created the best overclocking tutorials ever, before the Linus did, before all those copycats did, and they did a lot of views, guys, before even Linus had his channel. Keep that in mind. So 10900K. What else? Let me show you 3700X. Okay, 120 points faster than that CPU. 9900K is the same CPU by 100 points faster, and as you can see, multi-thread performance using 16 logical processors, and I'm only using 6 logical processors. It's not even 2 times faster, but it should be 3 times faster than me, and it's not even 2 times faster. This is how well this frequency is holding those 6 logical processors. Hopefully, guys, this makes sense. MSI Afterburner plus 85 megahertz overclock on the GPU, completely stable, no problem, and GPU. So we saw like 2 gigahertz frequency, and then it was thermal throttling a little bit because the Titan RTX video card starts its thermal throttle process after 62 Celsius, or when it's reaching 62 Celsius. And thermal throttle process is when it's lowering the frequencies, lowering the voltage, and lowering the wattage of the power consumption. Okay, because it's doing that when the component getting too hot. Okay, it has the limitation in terms of the temperature, thanks to the smart and intelligent engineers by Nvidia and Intel for that type of technology. So, and the plus 1000 megahertz overclock on the VRAM, which stands for the Video RAM GDDR6, and from 14,000 megahertz to 16,000 megahertz. I already told you that. So either 64 GPU benchmark. So Titan RTX was maximum overclock, as you saw, versus this 6-core 6-thread CPU. However, this is the best possible scenario when you can compare CPU versus the GPU. Of course, GPU will be always the fastest, and I was saying by 20 times, around 20 times. What I find out throughout this formula right now, you can see by about 18-17 times. So I was really close to the predictions. Okay, and as you can see, when you're going to add the secondary Titan RTX, the digits will go exactly double, because it's going to utilize the MGPU, multi-GPU technology feature, and RTX 2080 Ti video cards or Titan RTX video cards doing it pretty well when it comes to MGPU technologies, when it's utilizing multiple GPUs. I'm not talking about the SLI, I'm talking about the multiple GPUs, such as like Blender rendering and TrueDectane and some other professional applications. Okay, and when GPU is running OpenCL and CPU is running a heavily optimized machine code, which is the best possible scenario, 64-bit. Okay, hopefully this makes sense. The last benchmark that I want to show you before I will let you go, either 64 cache and memory benchmark, and the values that will not be changed even if I'm going to add 2 more cores and hyper-threading technology, will be the latencies. In terms of the NS, NS stands for nanoseconds. MS at the left top corner where we're benching was saying MS by the FPS. MS stands for milliseconds. NS stands for the nanoseconds. Okay, and it's as fast as possible, much faster than milliseconds. And as you can see, we're below 43 nanoseconds, and this pretty much the average results, like 43 or below 43 nanoseconds when I'm using this type of overclock, this type of tune. And level 1 cache 0.8 nanoseconds, level 2 cache 2.3 nanoseconds, level 3 cache 10.1 nanoseconds or 10 nanoseconds. This is unheard of latency delay, especially memory latency, 42.9 nanoseconds, which is the system RAM, communication between the system RAM and CPU, which is unheard of. Even 12,900K Intel CPU cannot do that with the DDR4 and even DDR5. Keep that in mind. This is unheard of when it's running at stock. I'm talking 12,900K running at stock, of course. Okay, the read and write copy bandwidth is almost 50 gigabytes per second or 50,000 megabytes per second. This is not megabits, this is megabytes per second, because if you're talking megabits, you gotta multiply it by 8. Hopefully, guys, this makes sense, and you will receive the megabits value. So level 1, level 2, level 3 cache will improve if I'm going to add more cores, because the stock value for these 16 logical processors is going to be 2100 gigabytes per second read, and the copy value for the L1 cache, so 200 gigabytes per second more than I'm receiving right now, but I'm only running 6 logical processors. Keep that in mind. This is how fast we are. Hopefully, guys, this makes sense. And when PC games will utilize only few cores, but it's going to look for that highest frequencies, it's going to be a Gucci. Instead of, it's not going to look for those more cores to be loaded. This is not how PC games works in 2022. It's utilizing about maximum 8 cores, and it's looking for it maximum 10. Some games can utilize even 10 cores, but the maximum looking for that highest frequency, because the frequency, as again in that algorithm, makes that FPS. Hopefully, guys, this makes sense. So pretty much I explained to you everything what you need to know today, and hopefully you enjoyed that. And let me real quick, I showed you that my resolution was set at 16K resolution, but as again for those naysayers, 16K resolution, 100% scale, and yeah. Thank you so much for watching CounterStrike Source PC game. For the first time was running 16K video resolution gameplay, and it was real deal. It wasn't the fake like those high school kids doing, and it wasn't through some get a solder tool, which is kind of fakeish. For me, it's kind of fakeish, because Nvidia DSR is much better DSR tool, and I trust Nvidia, because Nvidia creating video cards, it's not exactly how to do that resolution. Because when I was testing in 2015 2016 the Half-Life 2 with get a solder, I tested only few games with get a solder tool. All the games was tested with Nvidia DSR, because I learned how to modify the Nvidia drivers back in 2016. Okay, but earlier in 2015 2016 I was testing with get a solder tool, and what I find out, get a solder tool is using almost 3 times less VRAM and for the same type of resolution that Nvidia DSR, and it's showing 2 times more FPS. So it's kind of almost 2 times more FPS. So it's kind of doesn't make no sense. Okay, so I really trust, maybe there is 16K resolution in get a solder approach. I'm not saying it's not, but I gotta look at the open source as the software developer. I didn't look at his open source, because his tool is open source. But maybe it's some sort of approach, but I trust Nvidia, and just the way Nvidia does that through the DSR, this is how the real 16K native resolution screens will be in terms of the performance needed for this type of hardware. If I would have, let's say today, right now, 16K native resolution screen in 2022, which is impossible on this computer, this is exactly how performance will be. Okay, so hopefully, guys, makes sense. Go ahead and smash that like button. A lot of time, money, energy was invested. Share it with your CounterStrike Source PC gamers fans. Share it with the PC hardware enthusiasts. A lot of information was discussed, multi-angle information for all kind of different industries, as you can tell. And yeah, support me, guys. Subscribe, visit my ads, and I will see you till the next videos. Check out UHDking.com and check out 15360 times 8640.com. It's going to be like 15360x 8640.com. It's going to be the YouTube channel dedicated by UHD King for 16K video resolution, gameplays, and video resolution in general. Alright, guys, have a great 2022. For those naysayers, let me show it to you. This technology was available in 2018, but I recorded in 2022, February 2nd, 2022. This is what's up. Okay, and same experience can be done on RTX 2080 Ti video card. As we saw, the VRAM utilization was below 12,000 megabytes. And yeah, pretty much RTX 3090 will show 1.7 times faster, about like that, but we are going to test over the UHDking.com. RTX 4090 video card will show at least 3 times of the FPS. Keep that in mind, okay? Till the next time.